Hey, AP Physics 1, this is the 2005 AP Physics B, which is really AP Physics 1 now. It's a modified question to reflect kind of what you would see on the test. And you've got a pendulum. You'll notice that it gives you a length of a string, gives you a mass, and it wants us on the figure below, draw the free body diagram showing and labeling the forces on the bob and the position shown above. So we don't want to draw any of the components. We just actually want the forces. So first thing that we need to do is draw mg. So there is our first force. Notice that we have attached right here to the wall is a string, and then it goes to the ball. So there's got to be some tension going in this direction. So we're going to call it TH for horizontal tension. And then we've got one more coming out at an angle, and that one we're going to call it TP for the pendulum string. It's another tension. So now we have everything we need for that part. For the next part, it says it wants us to derive an equation for the tension and the horizontal string. Express your answers in terms of mg and any fundamental constants we need. So let's go back to this again. This is T, tension of the pendulum. This is tension in the horizontal string. And then finally we have mg. And so let's go ahead and take a look at this. Now that we have these things, because this drawing is not on that first page, we can add components to it. So let's go ahead and draw a component here and one here. And we're going to say that our axis is left and right and up and down. So this is plus y. This one is plus x. Our angle right here, they told us was 30 degrees. So this is 30. This is the opposite side. Here's our adjacent side. So this one's going to be TP times the sine of the angle. And then the adjacent side is going to be TP times the cosine of the angle. So let's go ahead and do this in both directions. Let's look at the sum of the forces in the x direction. We know those are 0. Going to the right, we have TH, so that's the horizontal string. And then going to the directly to the left is not TP. Remember, that's up to the left. It's TP sine of the angle. So minus TP times the sine of the angle, and that's equal to 0. So the tension in the horizontal string is really equal to TP times the sine of the angle. Next thing we're going to do is let's do the sum of the forces in the y direction, and that should be equal to 0 since it's at equilibrium. Going up, we see we have TP times the cosine of the angle minus mg, and that's equal to 0. So TP cosine of the angle is equal to m times g. Now at this point, we need to look and see what we've got. We do have TP on both sides. So let's do this. Let's go ahead and since we have everything here, we can actually go ahead and let's solve this one for TP. So TP is equal to TH over the sine of the angle. And on the other side, we can solve TP, so we can say TP is equal to mg over the cosine of the angle. Let's take what we have for TP here, and let's plug it into this side of the equation. So if we do that, let's change colors. Let's going to take this and plug it in for TP over here, because we want to find TH. So this would be mg over the cosine of the angle is equal to TH over the sine of the angle. We want TH by itself, so let's multiply both sides by sine of the angle. So this would be TH is equal to mg times the sine of the angle all over the cosine of the angle. And if you remember your trig, you remember that sine of the angle over cosine of the angle is equal to tangent of the angle. So TH here is equal to mg times the tangent of the angle, and we know that our tangent of the angle is actually equal to 30, so mg times the tangent of 30 degrees. The last thing they want us to do is calculate the, well, let's go ahead and put this TH in. Last thing they want us to do is calculate the tension in the horizontal string. So let's find it. So we have TH is equal to, if you remember back on the problem, they did tell us that the mass of this ball was 1.8 kilograms. So we're going to put in our mass, 1.8 kilograms, that's for M. Gravity, let's go ahead and use 9.8 just for fun. We can usually use 10, but we're going to use 9.8 here. And then we want to take that times the tangent of 30 degrees. So 1.8 times 9.8 times the tangent of 30 gives us approximately 10 newtons. And that is the end of this problem.